Welcome to the Environmental Protection Agency's presentation on management of hazardous chemicals at chemical warehousing and chemical distribution facilities. In 2021, the EPA published a joint safety advisory with the Occupational Safety and Health Administration and the Department of Homeland Security, Cybersecurity, and Infrastructure Security Agency focused on managing chemicals safely, securely, and in compliance with federal programs for chemical warehousing and chemical distribution facilities. Additionally, the EPA published an enforcement alert targeted at chemical warehouses and distribution facilities in 2021 to highlight common safety deficiencies observed in the industry and enforcement actions taken by the agency. This presentation serves as an additional resource for facilities engaged in chemical storage. In this presentation, we will address the types of operations in the chemical warehousing industry that are of focus, provide a summary of the EPA, Chemical Safety Board or CSB, OSHA, and DHS-CISA regulations applicable to these operations, and define common issues related to chemical management and safety. The regulations and common issues we will discuss are not exhaustive and are meant to be an overview of key chemical management and safety requirements. In addition, we will review several case studies and recent enforcement outcomes. By the end of this presentation, you will be able to identify key chemical safety regulations applicable to chemical distributors and manufacturers, identify common issues related to management of hazardous chemicals, as well as locate resources for the industry developed by federal agencies. Let's get started with a case study related to incompatible materials that highlights why intentional chemical management for chemical warehouses and distribution facilities is important. Consider a chemical distribution facility that stores and manages hundreds of different materials at a single warehouse location. The warehouse has a sprinkler system installed for fire suppression. You notice drums of ammonium bifluoride flake in fiberboard drums that are stored adjacent to drums of methanol. Both of these materials are stored in an area that is protected by the sprinkler system. What potential hazards are present in this situation? If you aren't aware, what information would you want to know about these materials to be able to evaluate chemical risks? When we look at the properties of the ammonium bifluoride flake, we observe that when exposed to water or high temperatures, this material can decompose to form hydrofluoric acid, ammonia, and nitrogen oxide gases. Hydrofluoric acid can cause severe skin burns, eye damage, or fatalities if exposed. In addition, methanol is highly flammable, with a National Fire Protection Association flammability rating of 3. Storing a flammable substance next to the ammonium bifluoride flake can result in the generation of the decomposition products in the case of a fire incident due to the heat. Additionally, as water also promotes the decomposition of ammonium bifluoride flake, storing this material under a sprinkler system also could result in acutely hazardous chemicals being generated in the event of a fire. Storing the ammonium bifluoride flake away from flammable materials and without water-based fire suppression reduces these risks. It is critical for facilities to properly evaluate chemical hazards and understand the physical and chemical properties of any materials stored on site. In this instance, we see how co-locating incompatible materials could result in compounding hazardous conditions as opposed to minimizing them. Now let's turn our attention to review common types of operations found in the chemical warehousing and chemical distribution industry. Our focus in this presentation is on chemical warehousing and chemical distribution, which can include facilities that process, formulate, blend, repackage, store, transport, and market chemical products. A chemical warehouse can be its own standalone facility where pre-manufactured products are delivered, stored, and transported. Or chemical warehousing operations can be a part of a larger manufacturing facility. Additionally, when determining chemical safety regulations applicable to a site, it is important to consider not just the chemical products being stored, but also any ancillary operations. For example, ammonia refrigeration is commonly used in chemical warehousing and distribution, and use of anhydrous ammonia has its own safety standards and requirements to adhere to. On this screen, we highlight photographs of several types of operations that could be part of a chemical distribution or warehousing facility. On the top left, the liquid receiver of an ammonia refrigeration system and associated piping is depicted. In this photo, we can see that there is ice buildup on some of the piping, a common safety issue for ammonia refrigeration, as it can create potential access issues to manual valves and other equipment components, and makes it difficult to visually inspect equipment for damage or integrity issues. On the bottom left, we see railcar unloading of propane at a terminal. The last two photos on the right show various types of chemical storage operations. The bottom photo depicts indoor chemical warehousing with plastic totes and super sacks. The top right photo depicts chemical storage in exterior above-ground storage tanks. Accounting for all the various sources of chemical storage at a facility when thinking about chemical safety management is critical. Let's take a closer look and review key federal regulations of importance related to chemical storage at chemical warehousing and chemical distribution facilities. The regulations highlighted on the screen are not exhaustive of all environmental, safety, and security requirements for chemical warehousing operations, but identify the primary regulations enforced by the Environmental Protection Agency, or EPA, the Chemical Safety Board, or CSB, the Department of Labor, Occupational Safety and Health Administration, or OSHA, the Department of Homeland Security, Cybersecurity and Infrastructure Security Agency, or DHS-CISA. Namely, let's focus on EPA's Clean Air Act, the Emergency Planning and Community Right to Know Act, or EPCRA, and the Comprehensive Environmental Response Compensation and Liability Act, or CERCLA. The CSB has accidental release reporting requirements. OSHA requirements that will be covered are the Process Safety Management Program, or PSM, and hazard communication, explosive and blasting agents, flammable liquids and emergency response, and planning standards. We will also touch on the DHS-CISA Chemical Facility Anti-Terrorism Standards, or CFATS, and the Maritime Transportation Security Act. Additionally, there may be state and local requirements that a facility is subject to that are not covered by this presentation. Although these federal agencies have their own individual regulations and programs related to chemical management, safety, and security, they also work together to share information in order to reduce risks associated with hazardous chemical incidents. Specifically, Executive Order 13650, issued in August 2013, created a federal interagency working group that includes EPA, OSHA, DHS, and several other agencies. The working group is designed to improve data management, interagency coordination, and strengthen community planning and preparedness. As we discuss each agency's regulations separately on the next few screens, think about the similarities between some of these programs and keep in mind that information submitted to one agency may be shared with others. First, let's review EPA's Clean Air Act. EPA is authorized under the Clean Air Act to regulate the safe handling and management of chemical storage through the Risk Management Plan Rule and the General Duty Clause. The Risk Management Plan, or RMP, is a requirement designed to protect human health and the environment from the effects of catastrophic releases of hazardous chemicals. RMP applicability is determined based on storage of a regulated substance at a stationary source over a certain threshold quantity within a process. The regulated substances and their threshold quantities under RMP are provided in 40 CFR Part 68, Subpart F. If you do not have a regulated substance at your site, you are not covered by RMP. The list of regulated substances is comprised of 77 toxic and 63 flammable chemicals. Remember, flammable mixtures are only subject to the rule if there is a regulated substance in the mixture above 1% and the entire mixture meets the National Fire Protection Association Level 4 rating. If you are subject to RMP, there are 3 different tiers of reporting requirements. The program level for a site depends on 1. A site's accident history, 2. The modeled off-site impacts from a worst-case release, and 3. OSHA process safety management applicability. If certain conditions are met, a facility may be required to develop a risk management program with hazard assessments, prevention program, and emergency response requirements. The prevention programs can consist of components such as documentation of safety information, development of a maintenance program, training, process hazard analysis, and maintaining accurate operating procedures. As part of documenting safety information, a facility has to ensure that the process is designed to comply with recognized and generally accepted good engineering practices that address industry-specific safe design, operation, and maintenance requirements. In addition to the RMP requirements, the Clean Air Act also authorizes the EPA to enforce the General Duty Clause, or GDC. This statute provides that facilities have a general duty to design and maintain a safe facility to prevent release and minimize consequences of any releases which do occur. There is no specific list of chemicals or threshold quantities that are subject to the GDC, but any chemical or mixture that would be considered an extremely hazardous substance is applicable. So, if you do not maintain regulated substances subject to RMP at your facility, you may still need to identify hazards associated with any extremely hazardous substances and meet certain minimum design standards. Next, let's review EPCRA, also known as the Emergency Planning and Community Right to Know Act. EPCRA's goal is to prepare communities for and protect communities from chemical accidents. Requirements for industrial facilities are provided in Section 302, Section 303, Section 304, Sections 311 and 312, and Section 313 of EPCRA. Section 302 of EPCRA focuses on emergency planning and requires a facility to notify the State Emergency Response Commission, or CERC, or Tribal Emergency Response Commission, or TERC, and Local Emergency Planning Committee, or LEPC, or Tribal Emergency Planning Committee, or TEPC, when an extremely hazardous substance, or EHS, is present on site at or above its respective threshold planning quantity, or TPQ. Section 303, Subpart D of EPCRA requires facilities to notify the LEPC or TEPC of a facility representative who will participate in the emergency planning process as a facility emergency coordinator if you store an EHS above its respective TPQ. Additionally, facilities are required to promptly provide any information necessary to modify community emergency response plans upon request by the LEPC or TEPC. Section 304 of EPCRA focuses on agency notification of accidental releases. Chemicals regulated under Section 304 of EPCRA include the EHS list included in Appendix A of 40 CFR Part 355, as well as hazardous substances defined under the Comprehensive Environmental Response Compensation and Liability Act, or CERCLA. Sections 311 and 312 of EPCRA require submission of safety data sheets and a Tier 2 chemical inventory form for hazardous chemicals stored on site above certain thresholds. In this context, hazardous chemicals are generally considered to be any material that requires a safety data sheet under OSHA Hazard Communication Regulations. The federal annual reporting deadline is March 1st for reporting on chemical storage for the previous calendar year. There are additional reporting requirements if you bring a hazardous chemical onto your facility for the first time in an amount that meets or exceeds the threshold. Additionally, state and local agencies should also be consulted for additional reporting requirements, including lower thresholds. Finally, EPCRA Section 313 covers the Toxics Release Inventory, or TRI. TRI reporting requires facilities in certain industries and who have more than 10 full-time employees to report annually on their pollution prevention and waste management activities, including releases of certain chemicals if they use or manufacture TRI chemicals above thresholds. Now let's revisit EPCRA Section 304 Release Notification Requirements in more detail and introduce a related requirement authorized by the Comprehensive Environmental Response Compensation and Liability Act, or CERCLA. EPCRA Section 304 and CERCLA Section 103 both focus on chemical release notification requirements, and although these statutes are interrelated, they also have key differences in their chemical lists, agency notification requirements, and applicable release conditions to trigger notification. The list of applicable CERCLA 103 chemicals are referred to as hazardous substances and are provided in 40 CFR Section 302.4. The list of applicable EPCRA 304 chemicals includes all CERCLA hazardous substances and EPCRA Section 302 extremely hazardous substances. If you have a qualifying release of a CERCLA hazardous substance, you will need to complete both CERCLA 103 and EPCRA 304 requirements. However, if you have a qualifying release of an EPCRA EHS, only EPCRA 304 requirements need to be completed. The quantity of a chemical release at which reporting is required is dictated by the reportable quantities, or RQs, which are listed in the regulations and are specific to the chemical. For EPCRA 304, the location of the release for a qualifying incident must impact environmental media off-site. A qualifying release under CERCLA 103 is triggered if any environmental media on-site or off-site is impacted. Note that environmental media can include unauthorized air releases or emissions. Once a release of a subject chemical has occurred above the threshold level, CERCLA 103 reporting requires notification to the U.S. Coast Guard National Response Center, or NRC. Note that the NRC is not a response agency, but serves as an emergency call center that logs initial reports for releases and other incidents. Once a release threshold has been met under EPCRA 304, notification is required to be made to the CERC or TURC and LEPC or TEPC. These agency notifications are required to occur immediately once a subject chemical reportable quantity has been exceeded. While there is no regulatory definition for an immediate notification, federal guidance generally defines this timeframe as approximately within 15 minutes of a release exceeding the RQ. Under EPCRA Section 304, written follow-up reports that summarize the actions taken to respond and to contain the release, as well as any known anticipated acute or chronic health risks associated with the release. With the immediate nature of the CERCLA and EPCRA release notification requirements, having procedures in place that clearly identify subject chemicals, their reportable quantities, and the notifications that need to be taken for a qualifying release are key to ensure compliance. Now we'll discuss another chemical release reporting requirement, this one implemented by the Chemical Safety Board, The CSB's Accidental Release Reporting Rule requires facilities that experience an accidental release of a regulated substance or extremely hazardous substance that results in a death, serious injury, or substantial property damage to be reported to the agency within 8 hours. Reporting can be accomplished with a phone call, submission of an online form, or by providing the NRC report number for reference, if an NRC report has been filed. This rule came into effect in March 2020 and allows the CSB to evaluate which incidents it should investigate. Now, let's review some of the most relevant regulations and statutes for chemical warehousing and distribution operations that are under the jurisdiction of OSHA. OSHA has a program referred to as Process Safety Management, or PSM, which is regulated under 29 CFR Part 1910.119. PSM is a very similar program to EPA's RMP rule. However, where RMP focuses on protecting human health and the environment from catastrophic releases, PSM aims to protect employees in the workplace from the effects of catastrophic releases. If a facility stores a PSM chemical in a defined process above the thresholds established in the regulation, development of PSM program is required. The PSM chemical list includes specific toxic, reactive, and flammable chemicals, referred to as highly hazardous chemicals. There is overlap in the chemicals subject to RMP and PSM. However, these chemicals have distinct thresholds for each program. For example, oleum, also known as fuming sulfuric acid, has a 1,000 pound threshold for PSM and a 10,000 pound threshold for RMP. There are differences in the PSM program requirements as compared to RMP. However, many of the core elements are the same, and facilities that are subject to both PSM and RMP frequently use a combined plan to satisfy both regulations. In addition, OSHA also has a general duty clause established by the OSHA Act of 1970, which generally requires employers to provide workplaces free from recognized hazards that are likely to cause death or serious physical harm to employees. This mirrors the Clean Air Act General Duty Clause and provides a means for OSHA to regulate chemical safety for processes or facilities that do not contain PSM-regulated substances. Facilities have an obligation to identify recognized serious hazards and mitigate them, even if there is no specific regulatory standard that applies to a particular hazard. OSHA's Hazard Communication Standard, or HCS, provided in 29 CFR Parts 1910.1200, is designed to ensure that information about chemical and toxic substance hazards in the workplace and associated protective measures is disseminated to workers. The HCS includes requirements for a written hazard communication program, container labeling, maintaining safety data sheets, and providing employee training. In the photo to the right, we see an example of HCS-compliant drum labeling of an ammonium hydroxide solution. The label contains product identifiers, supplier identification, signal words, precautionary statements, and we can see 3 hazard pictograms on the left side of the label. Requirements for manufacturing, keeping, having, storing, selling, transporting, and using explosives, blasting agents, and pyrotechnics is regulated under 29 CFR Parts 1910.109. Finally, the Flammable Liquids Standard, regulated in 29 CFR Part 1910.106, applies to the handling, storage, and use of flammable liquids that have a flash point below 200 degrees Fahrenheit. It contains key requirements for design and construction, ventilation, ignition sources, and storage. OSHA has several standards related to emergency response and planning, and we will be discussing two specific requirements. The first is Emergency Action Plans, or EAPs, which are regulated under 29 CFR Part 1910.38. Almost every business is required to have an EAP. For example, if fire extinguishers are required or provided in your workplace, and if anyone will be evacuating during a fire or other emergency, then your workplace is required to have an EAP. Plans are required to include emergency procedures, such as how to report fires and other emergencies, evacuation procedures, defining rescue and medical duties, and providing names or job titles of persons who can be contacted in an emergency. Employers are required to designate and train enough people to assist in the safe and orderly emergency evacuation of employees. The second requirement we will cover is included in the OSHA Hazardous Waste Operations and Emergency Response Program, or HAZWOPER standard, located at 29 CFR 1910.120. Subsection Q of this standard covers emergency response to hazardous substance release. The development of an emergency response plan with more specific requirements than an EAP is required unless employees are not permitted to assist in handling emergency hazardous substance releases. The regulation also establishes requirements for training of first responders and other impacted roles and dictates that refresher training shall be conducted at least annually. Additionally, medical surveillance requirements for hazmat team members are established. Lastly, let's highlight two key chemical management requirements under the jurisdiction of the Department of Homeland Security, Cybersecurity and Infrastructure Security Agency. The first is the Chemical Facility Anti-Terrorism Standard, or CFATS, which is regulated under 6 CFR Part 27 and identifies and regulates high-risk chemical facilities to reduce the risk of certain hazardous chemicals being weaponized. Appendix A of 6 CFR Part 27 lists more than 300 chemicals of interest and their respective screening threshold quantities, or STQs, and associated concentrations. If your facility does not possess a chemical of interest, CFATS does not apply. If you possess a chemical of interest above the STQ, the facility must submit a top screen survey to the Cybersecurity and Infrastructure Security Agency within 60 calendar days to determine if your site is high risk. High-risk facilities are required to develop a security plan. The second requirement related to DHS falls under the Maritime Transportation Security Act of 2002, which is designed to ensure greater security for the nation's seaports and waterways. Through this act, the U.S. Coast Guard regulates waterfront facilities that meet certain applicability factors, and facility or vessel security plans may be required to be maintained. Now that we have given an overview of key federal regulations of importance related to chemical storage at chemical warehousing and distribution facilities, let's look at the regulatory applicability for a specific material, peracetic acid, in more detail. Consider chemical company XYZ, a chemical distribution facility that supplies a variety of products to its customers. It stores two different disinfectants, one labeled as disinfectant X and another as peracetic acid 15%. Disinfectant X is stored in 275-gallon plastic totes, and the maximum quantity on site at any time is 10 totes. The facility also stores no more than 5 55-gallon plastic drums of peracetic acid 15%. Peracetic acid is a chemical on the RMP, EPCRA EHS, CFATS, and PSM lists. Based on the materials stored at this facility, is peracetic acid reportable under RMP, EPCRA Section 302 or EHS notification, EPCRA Section 312 or Tier 2 reporting, CFATS, or PSM for chemical company XYZ. A good first step in evaluating applicability under these regulations is to review the chemical compositions of these products presented on their safety data sheets, or SDSs. On the left, we have an excerpt from the SDS for disinfectant X. Although the name does not indicate that it contains peracetic acid, we see that Section 3 from the SDS shows the chemical present at concentrations ranging from 10 to 20%. Screening of SDSs is critical. You may discover chemicals subject to regulations that you might not anticipate present in the product. When an SDS has a range, you need to use the upper end of the range for determining regulatory threshold calculations for the programs we are considering. For this example, you would use 20%, the upper end of the range for your threshold calculations. On the right, the composition of the peracetic acid 15% material is present. Although this material is called peracetic acid, we can see that it contains three chemicals in Section 3 of the SDS: peracetic acid, hydrogen peroxide, and acetic acid. Both hydrogen peroxide and acetic acid are subject to several regulations we have discussed, and therefore would also need to be addressed. However, our focus is on peracetic acid, which is present at concentrations ranging from 14 to 17%. For this example, you would use 17%, the upper end of the range for your threshold calculations. Next, it is important for a facility to determine what the regulatory thresholds and qualifiers are for each program. The tables presented are a screenshot taken from Cameo Chemicals, an online tool developed and maintained by the federal government. Cameo identifies chemical regulatory applicability, including thresholds and qualifiers, provides chemical and physical properties, and other useful information for emergency response planning related to the chemicals being stored on site. The three tables provide the threshold and qualifiers for peracetic acid for EPA, DHS, and OSHA, respectively. Just glancing through the values presented, we can observe that there is a range of threshold triggers. A facility is subject to the RMP program if they store more than 10,000 pounds of peracetic acid, whereas the EPCRA Section 302 EHS reporting threshold is only 500 pounds. The CFATS threshold for peracetic acid is 1,000 pounds, as long as the mixture contains concentrations of more than 1% peracetic acid. The PSM threshold is also 1,000 pounds of peracetic acid. However, there is an exemption for any mixture that contains less than 60% acetic acid. With varying thresholds and chemical qualifiers for each regulatory program, having a means to track this regulatory information and screen against a facility's chemical use and storage, including evaluating changes, is extremely beneficial. Now that we have determined the chemicals present in these materials and their respective concentrations and established what threshold levels apply for each program, we are ready to calculate the peracetic acid storage amounts and compare them to the threshold levels for each regulatory program of interest. Using the maximum storage volume of each product, as well as their respective densities and maximum concentrations of peracetic acid, the site-wide maximum peracetic acid amount can be determined. These calculations give 5,247 pounds of peracetic acid stored as disinfectant X and 445 pounds of peracetic acid stored in peracetic acid 15%. Before comparing to regulatory thresholds, in this case, the storage contributions from each material must be summed across the entire facility, giving a maximum peracetic acid storage amount of approximately 5,700 pounds. With the total storage amount determined, applicability determinations can be made for the 5 regulatory programs of interest. In the case of RMP program applicability, the total storage amount does not exceed the threshold level of 10,000 pounds, and therefore, peracetic acid would not be reportable under RMP. the facility does exceed the 500-pound EPCRA 302 threshold, and therefore would need to make the proper notifications to state and local agencies. It is important to note that peracetic acid 15% on its own does not exceed the EPCRA 302 threshold, but since the site-wide peracetic acid storage is greater than 500 pounds, all sources of peracetic acid must be reported. Since EPCRA Tier 2 reporting requires facilities to report EHSs stored above the TPQ or greater than 500 pounds, whichever is less, Tier 2 reporting of peracetic acid is required. Additionally, the facility stores more than 10,000 pounds of the overall peracetic acid cleaning mixtures between disinfectant X and peracetic acid 15%. Therefore, the overall mixtures should also be included in the Tier 2 report. Although there is less than 10,000 pounds of the peracetic acid 15% mixture, the chemical compositions and hazards of these two materials are similar enough that they should be considered together for Tier 2 reporting. Next, the facility exceeds the 1,000 pounds CFATS threshold for peracetic acid, as well as the 1% concentration qualifier. Therefore, the site would need to submit an initial top screen report. And finally, although the storage of peracetic acid is greater than the 1,000 pound program threshold for PSM, it is only reportable if it is also present in solutions with acetic acid greater than 60% by weight. As acetic acid in either product did not exceed 20% by weight, PSM would not apply to peracetic acid at this facility. A strong knowledge of the quantities and compositions of materials stored at a facility and correctly assigning the appropriate regulatory threshold levels and chemical qualifiers is beneficial for a robust compliance program at chemical warehouse facilities. Now that we have a framework for the key applicable federal regulations, we will now review common chemical storage issues at chemical warehousing and chemical distribution facilities. We will cover both applicability issues and chemical management issues. Applicability issues refer to situations of incorrectly evaluating whether a facility or process is subject to a regulation. Chemical management issues focus on real-life examples of common chemical storage safety issues observed during EPA inspections. One common applicability issue observed for chemical warehouses and distributors is that a facility fails to file and implement an RMP or PSM plan or to submit required EPCRA reports, often because facility inventory management systems failed to flag that chemical inventories have exceeded a regulatory threshold or to identify the chemical as potentially subject. There are a variety of situations in which this could happen. For example, the wrong threshold levels could be applied. An increase in inventory of a certain chemical that exceeds a threshold is not noticed or tracked, or perhaps a chemical qualifier is misinterpreted. The primary solution to avoid these issues is to maintain a robust facility inventory management system, where personnel entering information into the system are well trained on regulatory applicability. Another common issue is lack of attention to solutions or mixtures. It is much simpler to identify a chemical of concern when it is a pure material. However, safety data sheets or other compositional data sources should be reviewed for mixtures to screen for these chemicals which may be present in materials that are not always obvious. Additionally, special attention should be paid to any relevant chemical qualifiers, which may include concentrations, physical state, or type of operations that the material is used in. Incorrectly applying these qualifiers may lead to underreporting. A third common applicability issue relates to flammable mixtures and EPA RMP applicability determinations. Flammable mixtures with an NFPA flammability rating of 4 are subject to RMP if stored in quantities of 10,000 pounds or more. When the concentration of the regulated flammable substance in the mixture is at 1% by weight or more, the entire weight of the flammable mixture must be applied towards the 10,000 pound threshold, not just the individual flammable chemical or chemicals. Let's look at an example of this. A facility stores a material, referred to as Mixture X, in a tank that contains 9,000 pounds of butane and 1,001 pounds of water. Mixture X meets the criteria for an NFPA rating of 4. First, let's look at the individual chemicals. Butane is a listed substance on the RMP list, with a threshold of 10,000 pounds. The storage of butane is 9,000 pounds, which does not exceed the threshold and would not be a trigger for RMP. However, flammable mixtures with an NFPA rating of 4 are a subject category on the RMP list with a threshold of 10,000 pounds. As the total storage amount of the NFPA 4 mixture is greater than that amount, the facility is subject to RMP. Note that PSM also has requirements for flammable liquids and gases under a different classification system. Let's dig deeper and look at some common chemical management issues observed from EPA inspections. When determining applicability for EPCRA 302 EHS notification or EPCRA 312 Tier 2 reporting, it is important to evaluate storage quantities across the entire facility and to recognize that there is no container size below which there is an exemption, although there may be other exemptions that apply. If we observe the picture on the right, we see containers and bags, totes, 55-gallon drums, and 15-gallon drums. Storage amounts of extremely hazardous substances for EPCRA 302 reporting and Tier 2 reporting need to be totaled across all these containers and materials to determine whether a threshold has been exceeded. Additionally, hazardous substances with similar chemical compositions and hazard profiles should be combined for Tier 2 reporting determinations. Keep in mind that other ancillary storage needs to be considered as well, such as maintenance areas. Another issue observed relates to coordination with local emergency responders. Many of the regulations discussed in this presentation contain some form of required communication with local agencies. For facilities subject to RMP, coordination with emergency responders is required on an annual basis. Note that there is also an upcoming requirement for stationary sources that contain RMP Program Level 2 or Level 3 processes to conduct annual exercise of their emergency response notification mechanisms before December 19th, 2024. For responding facilities that have trained employees to respond to accidental releases of regulated substances, there are additional requirements to conduct emergency response field exercises and tabletop exercises by December 19th, 2024. These activities are required to be coordinated with local public emergency response officials, including inviting them to participate. Our next chemical management issue relates to the integrity of tank systems and piping. On the photo on the left, we can see visible rusting on the piping entering the building wall, as well as on the piping running beneath the platform. On the other photo on the right, we see a close-up photo of a chemical storage tank and associated saddle, which supports the tank and holds it in place. Rusting and visible evidence of potential tank integrity issues are observed where the tank and saddle meet. Facilities should refer to local fire codes as well as industry standards to develop tank and piping inspection programs. These programs can consist of visual inspections to flag any potential issues, as well as routine integrity testing. The type of inspections required are determined by many factors, including the material being stored or transported, the materials of construction, and the age of the tank or piping. Without a robust inspection program in place, corrosion and integrity issues can develop, potentially leading to equipment failure. Inspection programs are designed to flag issues and trigger more complex inspections and analyses as needed to ensure safe equipment operation. As discussed in our previous case study of the warehouse facility that stored ammonium bifluoride flake and methanol adjacent to each other, storage of incompatible materials in close proximity can create additional hazards in the event of chemical release. It is critical for facilities to properly evaluate chemical hazards and understand the physical and chemical properties of any material stored on site, and to develop procedures for employees to follow on how to avoid co-location of incompatible materials. A safety data sheet is a valuable source for locating information on potential co-location hazards. Section 2 of a safety data sheet identifies hazards associated with the material, and Section 10 lists the stability and reactivity. Additionally, one method for avoiding incompatible chemical storage is to determine what kind of compatibility group a material belongs to. Examples of these groupings are things like acids, bases, oxidizers, reducers, and flammables. Once you understand which compatibility group or groups a material belongs to, you can identify what other groups are incompatible with that material. For example, common incompatible groups for oxidizers are flammables and combustible and organic materials. In the picture on the bottom left-hand corner of the screen, we see the storage rack on the left is labeled acid, and the storage rack on the right is labeled base. Mixing of acids and bases can generate excessive heat and can even lead to an explosion. Acids and bases should not be co-located together. In the picture on the right, we also see an example of acids and bases being co-located together. Concentrated sulfuric acid is stored in the blue drums, and caustic potash is stored in the black drum. Let's use this example to highlight another chemical compatibility tool available. Cameo Chemicals has a chemical reactivity tool that allows the user to add certain chemicals to determine if they are compatible. Here we see a screenshot of the Cameo Chemicals reactivity tool. We have already searched and added potassium hydroxide, or potash, which is shown on the left-hand column of the table, and sulfuric acid, which is the row heading on the right. Based on the materials added to your profile, the tool creates the cross-reference we see here, evaluating for any hazards associated with mixing these chemicals. Mixing of these two materials has been identified as incompatible, and as such, the materials should not be stored in proximity to each other. Reaction of these two materials may generate heat and gases, result in an intense or explosive reaction, and generate reaction products that are corrosive and toxic. Next, let's look at chemical management issues related to fire protection or other safety systems for chemical storage. In the photo on this screen, we see wooden storage containers stacked in a warehouse such that they almost touch the ceiling. The room has a sprinkler fire protection system. However, with the storage of materials so high, there is not sufficient clearance for the sprinklers to work properly in the event of a fire. Flammable materials require special consideration to ensure that the buildings they are stored in are appropriately designed structurally and have the proper fire protection. This may include installation and functional testing of alarms and sprinklers or other fire suppression systems. In the event of an accidental release or other emergency event, adequate spacing of chemical storage to allow access to affected materials by facility personnel or emergency responders is key. If a response is delayed due to access issues, that can exacerbate the effects of a release event. Chemical storage and emergency exit pathways need to be easily accessible in the event of emergency or release. In the center picture on the slide, we see ice buildup from a refrigeration system, which is so significant it is partially blocking the stairway access for emergency response and egress. On this screen, we see a few examples of inadequate secondary containment. We see materials that are stored directly on the ground, with no mechanism for capturing or containing materials in the event of a release. There are a variety of secondary containment requirements prescribed by fire codes, industry standards, and local, state, and federal regulations. Facilities should make sure they are meeting the most stringent requirements from these codes, standards, and regulations. Chemical labeling is an important aspect of chemical safety management. There are a variety of requirements for labeling materials in areas such as containers, equipment, piping, building entrances, and alarms, to name a subset. Labels provide critical information to individuals about the properties and hazards of materials present in a container or in a specific space. The examples are missing some critical labels identifying chemical hazards. On the left, there is a diesel tank shown located just behind a parking area. The tank contains no visible marking or labels to identify the contents, and in addition is missing the NFPA placard, which would show the presence of a combustible hazard. On the picture on the right, we observe the entrance to an ammonia refrigeration system engine room. There are a number of deficient signage issues seen here. Engine room doors are required to have NFPA 704 placards. Additionally, every machinery room entrance is required to have a sign to indicate that only authorized personnel are permitted to enter. We can see that there is some kind of alarm or signal above the door. This is an ammonia alarm, and it is also required to be labeled appropriately. These requirements are recommended by the International Institute of Ammonia Refrigeration, Standard for Safe Design of Closed-Circuit Ammonia Refrigeration Systems. Proper signage and labeling of chemical hazards is a vital safety measure. Now that we have covered common chemical storage issues, let's take a look at 3 recent enforcement cases from EPA at chemical warehouses and distribution facilities focused on chemical storage issues. EPA has taken enforcement actions and assessed penalties against several chemical warehouses and distribution facilities across the country, sometimes pursuing criminal enforcement. We will look at 3 examples of enforcement actions at facilities located in Rhode Island, Florida, and Kansas. First, we will look at enforcement action taken at Mann Chemical Company located in Warwick, Rhode Island. EPA inspected this facility in 2011 and 2013, with these inspections ultimately leading to a criminal investigation in coordination with OSHA, DHS, and local agencies. The facility was storing 92 drums of hydrofluoric acid at 70% concentration on site, but had not filed an RMP for this process. Hydrofluoric acid contained in solutions at concentrations of 50% or greater is an RMP-regulated substance and has a threshold level of 1,000 pounds. The total weight of hydrofluoric acid stored on site in this process was approximately 46,000 pounds, greatly exceeding the RMP threshold. In addition to the reporting issue, numerous other chemical safety issues were identified, including incompatible materials stored together, degrading tanks, and lack of proper fire suppression. A tank with visible integrity issues from one of the site inspections is shown in the photo on the right. Man Chemical was issued 3 compliance orders and a $200,000 fine with 3 years of probation. Our next example comes from enforcement action at a propane cylinder refurbishment facility located in Tavares, Florida, which stemmed from an incident at the site in 2013. At the Blue Rhino facility, which is owned by Farrell Gas Incorporated, 20-pound liquid propane cylinders are refurbished and refilled prior to distribution to retail locations. As part of the operations, the facility had a 4-acre storage yard where full and empty propane cylinders are stored. On July 29, 2013, workers at the facility improperly vented several cylinders to atmosphere, which caused propane to collect in the storage yard. During the venting, a spark from a forklift ignited the vented propane gas, resulting in a fire that caused the relief valves in other cylinders to release propane and create a chain reaction of explosions. The fire and explosions injured workers and caused approximately $3.5 million in damage, including to some off-site structures. EPA investigated the incident and alleged that Blue Rhino had violated the General Duty Clause of the Clean Air Act by failing to identify hazards that may result from accidental releases. Although the site was determined not to be subject to RMP under the General Duty Clause, the site had an obligation to design and maintain a safe facility and take steps to prevent accidental releases. Farrell Gas reached a settlement agreement with the EPA and the Department of Justice, agreeing to pay a $400,000 civil penalty. In response to the accident, the facility made a number of changes, including installation of new equipment, a revised training program, conducting a process hazard analysis, and designing a vent zone. Operating procedures were revised to specify that bleeding of cylinders could only occur in the designated vent zone, and to ensure that cylinders were truly emptied before storing. Our third enforcement example centers around a facility that mixed incompatible materials together, which resulted in a catastrophic release. MGP Ingredients, or MGPI, in Atchison, Kansas, operates a gluten, starch, and alcohol production facility. In October 2016, a routine delivery of sulfuric acid was conducted by Harcross Chemicals to unload the sulfuric acid. The MGPI operator unlocked the sulfuric acid fill line. However, the sodium hydroxide fill line was also unlocked, looked similar to the sulfuric line, and was not clearly marked. The driver inadvertently hooked the sulfuric acid hose from the delivery vehicle to the sodium hypochlorite fill line, and the two chemicals mixed. These two materials are incompatible, and the 4,000 gallons of sulfuric acid mistakenly combined with 5,800 gallons of sodium hypochlorite, forming a dense cloud of toxic chlorine gas and other chemicals. From the picture on the bottom of the screen, you can see how closely the sulfuric acid and sodium hypochlorite lines were in relation to each other, and how since the lines weren't labeled, it increased the likelihood for this kind of error to occur. Approximately 11,000 citizens in the area were advised to evacuate or shelter in place, and approximately 140 people, including members of the public, sought medical attention as a result of the incident. The top photo shows a picture of the chlorine gas cloud during the incident. MGPI and Harcross were each fined $1 million for violating the General Duty Clause of the Clean Air Act. This is another instance where neither sulfuric acid in this form nor sodium hydroxide are present on the RMP chemical list. However, the facility still has an obligation to take steps to prevent chemical accidents and mitigate the impacts of release events. If additional precautions such as line labeling, automatic shutoff valves or remote control of valves, and improved operating procedures had been in place, this could have helped prevent an accident of this scale. As we have covered in this presentation, there are a number of chemical safety regulations enforced by EPA, OSHA, and DHS that chemical distributors and warehousing operations are subject to. Companies must ensure that their chemicals are managed safely, securely, and in compliance with these programs to help prevent chemical accidents and security incidents. EPA, OSHA, and DHS released a joint safety advisory, and EPA published an enforcement alert in November 2021 focused on chemical warehouses and distribution facilities. A list of references to compliance resources, as well as the safety advisory and enforcement alert, are provided on the next 2 slides. Thank you for attending this presentation.